In this video, PCA is going to send an Ethernet frame to PCB, and PCB is going to send an Ethernet frame to PCA. We're going to examine how switches S1 and S2 build their MAC address tables, and also how they forward frames based on the information in those MAC address tables. PCA has an Ethernet frame to send to PCB. The source MAC address of the frame is 000A and the destination MAC address is 000B. The Ethernet frame is sent to switch S1. S1 receives the Ethernet frame, examines the source MAC address, and notices that this MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that this MAC address is not in its table, so it floods it out all ports. PCB receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices that that is a match and receives the rest of the frame. The Ethernet frame continues to be forwarded to switch S2. Switch S2 examines the source MAC address of the frame and notices it is not in its MAC address table, so it adds the MAC address and the incoming port to its MAC address table. Next, switch S2 examines the destination MAC address, notices that is not in its MAC address table, so it floods it out all ports. PCC receives the Ethernet frame and its MAC address does not match the destination MAC address of the Ethernet frame, so it does not accept the rest of the frame. The router receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notice it is not a match, so it does not receive the rest of the frame. Now let's have PCB sending a frame back to PCA. The source MAC address of the frame is 000B and the destination MAC address is 000A. PCB sends it to switch S1. S1 notices that the source MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that MAC address is in its MAC address table, so it sends it out just port 1. PCA receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices it is a match, so it receives the rest of the frame. In this video, PCA is going to send a packet to the internet because the destination IP address is on another network. So in this case, the source MAC address is that of PCA. The destination MAC address is that of the router of 000D. So the Ethernet frame is sent to switch S1. Switch S1 receives the frame, examines the source MAC address, which is in its MAC address table. So it just simply refreshes the 5-minute timer. It examines the destination MAC address, and because that destination MAC address is not in the MAC address table of switch S1, it floods it out all ports. PCB receives the Ethernet frame, and because the destination MAC address does not match its own MAC address, it does not accept the rest of the frame. Switch S2 receives the Ethernet frame, examines the source MAC address, which is in its MAC address table, so it also simply refreshes the 5-minute timer. It examines the destination MAC address of the frame, which is not in its MAC address table, so it floods it out all ports. PCC gets the Ethernet frame, and because the destination MAC address does not match its own MAC address, it does not accept the rest of the Ethernet frame. The router receives the Ethernet frame, and because the destination MAC address does match its own MAC address, it accepts the rest of the frame. Now we'll look at the Ethernet frame coming from the router back to PCA. The source IP address is the IP address actually of a device on a remote network. The source MAC address is that of the router at 000D, and the destination MAC address is that of PCA. The frame is sent to switch S2. S2 receives it, examines the source MAC address, which is not in its MAC address table, so it adds it. It then examines the destination MAC address, which is in its MAC address table, so it forwards it out port 1. S1 receives the Ethernet frame, examines the source MAC address, which is not in its MAC address table, so it adds it to its MAC address table. It examines the destination MAC address, which is in its MAC address table, so it goes ahead and just forwards it out port 1 towards PCA. PCA examines the destination MAC address, and because it is a match, it accepts the rest of the frame.
Hi, my name is Navjyoti Sharma, and I'm Product Manager at Cisco. I'm very excited to introduce Cisco 5600 series of switches and familiarize you with some of their leading-edge features. The Cisco Nexus 5600 platform is the next generation of switches in the highly successful Cisco Nexus 5500 series of switches. It's ideal for enterprise-class data center deployments. This platform delivers an innovative architecture gigabit of InfiniBand over Ethernet and native connectivity. The Cisco Nexus 5600 offers integrated Layer 3 line rate.
In this video, we're going to see PCA send an ARP request for the MAC address of PCC. PCA has an IP packet with the source IP address of itself, 192.168.1.110, and the destination IP address of PCC at 192.168.1.50. So it needs to know what the destination MAC address will be. Because the source and destination IP addresses are on the same network, the destination MAC address will be that of the destination IP address of PCC at 192.168.1.50. So PCA checks its ARP cache for the IP address 192.168.1.50. Because it is not in its ARP cache, it will put the packet on hold and create an ARP request. The ARP request contains the target IPv4 address. This is the IPv4 address which is known by PCA, and the target MAC address which is unknown. This is what PCA is wanting to find out. The ARP request is sent as a broadcast, so everybody on the network will need to examine this Ethernet frame and process the ARP request. So PCA sends it to the switch. Because it is a broadcast, the switch will flood it out all ports except for the port that it came in on. PCB receives the broadcast, so it must process it, and its ARP process examines the ARP request. It compares its own IPv4 address against the target IPv4 address, and notice that they are not the same, so it doesn't need to send an ARP reply. The router R1 also receives this ARP request. Its ARP process examines its own IPv4 address and compares that against the target IPv4 address, and also realizes this is not its IPv4 address, so it does not need to send the ARP reply. By the way, routers will not forward ARP requests out other ports. PCC receives the ARP request, compares its IPv4 address against the target IPv4 address, and notices that it is the intended target of the ARP request, that the target IPv4 address does match its own IPv4 address. So PCC will need to send an ARP reply. In the previous video, we saw an ARP request from PCA looking for the MAC address of PCC. In this video, we will see the ARP reply in response to that ARP request. PCC, when it received the ARP request, examined the target IPv4 address and compared it against its own IPv4 address and noticed that it was the intended target. So PCC will generate an ARP reply in response to that ARP request. The ARP reply includes its own IPv4 address and its own MAC address. It is sent to PCA. ARP replies are sent as a unicast, so the destination MAC address is that of PCA. PCA receives the ARP reply in response to its previous ARP request. It takes the information, the sender IPv4 address and the sender MAC address, and adds that information to its ARP cache. PCA can now take the packet, the original packet destined for PCC, take that packet off hold, and has the information it needs to send that packet to PCC. So it takes the information from the ARP cache, the MAC address, and adds that to the Ethernet header as the destination MAC address. PCA can now forward this packet in the proper Ethernet frame onto PCC. In this video, PCA has an IP packet, source IP address itself at 192.168.1.110, and destination IP address 10.1.1.10, which is an IP address on a remote network. So the destination MAC address will be that of its default gateway, 192.168.1.1, the router R1 in this case. PCA checks its ARP cache for that IP address, 192.168.1.1, and there's no entry with a MAC address. So it puts the packet on hold and creates an ARP request. The ARP request has the IP address of the router, 192.168.1.1, and the target MAC address is unknown. The destination MAC address of an ARP request is a broadcast. So it will be sent to the switch, and the switch will flood it out all ports except for the incoming port. PCB receives the ARP request, compares its own IPv4 address against the target IPv4 address in the ARP request, and notices it is not a match, so it is not the intended target. PCC receives the ARP request, compares its IPv4 address against the target IPv4 address, and it is not the intended target either. Router R1 receives the ARP request, compares its IPv4 address against the target IPv4 address, and it is indeed a match. It is the target of the ARP request. So router R1 will issue an ARP reply in response. It will include its own MAC address, 000D, along with its IPv4 address. The destination MAC address of the ARP reply is a unicast directed for PCA. So it is a destination MAC address of 000A, so PCA receives the ARP reply. PCA, when it receives the ARP reply in response for its ARP request, sees the target IPv4 address and the target MAC address and adds that to its ARP cache. It now has the information it needs to forward the packet which is on hold. So the destination MAC address is now going to be 000D, that of the router R1, its MAC address. And now PCA can forward the frame onto router R1.